Hello everyone. Today we'll have the tutorial on Fusion 360 drawing, 3D modeling, and we'll learn how to export it to Inventor, new assembly, and do the dynamic simulation. Okay. Now, in the drawing tutorial, we'll discuss most of these commands and what we need to do to prepare for exporting to Inventor for the dynamic simulation. Okay. So for this tutorial, we will draw a shaft as well as some other components, and I already have drawn a mechanism that will use it in the Inventor dynamic simulation. Okay, uh, before starting drawing, you have to learn about the environment here. Okay, so I'll start by discussing these views, which will become handy in sketching. Okay, so if you click on it, this is the origin. It will show directly. This is the x-axis, the y-axis, and the z-axis. Okay, it's important to note how the axes are oriented by default, because in some softwares these axes are changed by default. So if you draw here vertically, for example, in Inventor it will be horizontal because the z-axis is in this direction. Just important to keep in mind, because when you export and import to another software, it may look in different orientation. So this is the reason why. So you either account for it when drawing or rotate it after the fact, after drawing them. I'll show you how to do the rotating, inshallah. Okay. Then we have the most important thing, which is the planes. These planes are important since any 2D sketching, for start 3D modeling, you have to select the drawing plane or surface. Okay, so you either select here first and then start sketching, which is this button, or you sketch and select one of these or any other surface that you have already drawn. This is the view legend. By setting home, you will go to the default position where Z is perpendicular to the drawing plane. Okay, here we have also some other commands. Orbit is to maneuver around and change the view. After you're done, you can press home to go back to the default position. Look at will come handy when you're trying to change the drawing surface. We'll come back to it later. Pan is to move, and the rest are zoom, which can be done with the scroll wheel. Also, pan can be done using the middle button or pressing on the scroll wheel. You can pan through the drawing. Okay, these are the basics. So to 3D model, you have to keep in mind that we use 2D sketches to produce our 3D objects. Okay, so since we are drawing shaft today, okay, we'll start by drawing a circle and extruding it. See, when I press, okay, let's go back. When I press create sketch, it prompts me to select which plane I want to draw in. Okay, so let's say we'll draw in the XY plane. Okay, it changes our view to the XY plane. Let's go back again. I will say finish sketch. Alternatively, you can select the XY plane and create a sketch. Okay. Now here you can draw a line. Very simple. You specify the dimension. Let's say 100 in millimeters. The default unit is. and then you press tab to change the degree. Let's say 30. Okay, here is our line. You have a rectangle, same thing. You set the dimensions with the keyboard, press tab to go to the other dimension. Okay, now since this is a closed surface, Fusion will shade it with light blue, and if selected, it will be dark blue. Okay. Now we'll select the XY plane and sketch, and we select the circle, set our dimension to be 50, and hit enter. Okay, now we have the closed area highlighted in light blue, and we can either finish sketch by pressing this button or this button. Here we have the first circle. Okay, now we'll go to the 3D solid command, extrude. Let's go back, it was already highlighted. We'll select extrude. Since this is the only surface we have, it already picked up it automatically. So extrude is basically taking your 2D sketch and give it dimension in the perpendicular axis. So you can either add height by using this arrow, but keep in mind it goes only by increments of 5 in this case, or you can specify the height manually. Let's say I will want it to be 20 centimeters long, which is 200 millimeters. Okay. Now when you go to the options, you have to note that the operation is creating a new body. So let's press OK. And here we have a new section called bodies. Okay. Now I want to make my shaft hollow. So what I will do, I'll have to do a circle and cut that circle along the dimension of the shaft. Okay. So what you can do is press maybe look at. Okay. So it takes us to the XY plane. Create sketch. Also still requires selecting the plane. So we'll select the top of the shaft. Okay. Then we'll create our circle which we want to cut through the material. Okay. Put the dimension to be 40 and hit enter. When we finish the sketch, go back to the original. It's not necessarily to go back, but this is just to show you how it looks like now. Then we'll hit extrude again to make the cut. Now we'll select this surface. Now we have two options, either to go this way and make it another extrude with a step shaft. This is the first diameter and this is the second diameter, or go into the opposite direction. And you don't have to go all the way. Okay, you can go to half depending on what you want to draw. And if you go beyond the drawing, it will just cut for the length of the solid. Okay, and here you can see the operation change to cut. If you make it here, the operation changes to join. What join means, since we create another cylinder, it will join it with the previous cylinder and it will still be body one whole body. You can select to make it a new body. And when you press enter, we have two separate bodies. Okay, let's go back and by Control Z undo what we did because we want to make the cut. So we'll select the surface and go into the solid. Either press OK or enter. Now we have our hollow shaft. Okay. Next we'll discuss revolve. So I'll show you how to draw a cone first, then we will draw something into the shaft. We'll go to a new drawing. Let's say we want to draw a cone that's revolved around the z-axis. We see the z-axis. This is the z-axis, and that's what we'll revolve the cone about. So we will select the xy and start sketching. Sorry, if we are trying to do it around the z, we have to select the z and either the y-axis or the x-axis. Okay, either this one. Okay, let me show you both of them. You hold Control and select multiple ones to show them together. You either select this one and revolve it around z, or you will select this one and revolve it around z. Okay. Now you'll see that you don't have to revolve it all the way. It depends on what you need to do. Okay, so I will hit this. Oh, sorry. I will select this plane and start sketching in it. Now, what's a cone? Cone basically is a triangle that has been revolved 360 degrees. And I use the line command to draw it. Let's do it again. So I select the line. Okay. And hit click the mouse. When I'm done with the dimension, click the mouse again. Okay. Now it's light blue indicates that it's a closed surface area. Finish the sketch. Now we'll select the revolve command. Now this is the option you are currently selecting. You are selecting the axis of rotation. So let's select the z-axis. You can press it here, which is more preferable than using the z-axis, because sometimes you'll revolve around another axis or an edge, for example. So you don't always have the privilege to use these axes. So we'll select this one. It's automatically set to 360 degrees. Okay. In case this is not the correct surface you are trying to revolve, I will Control Z. See, here he picked it up automatically. But if you want to change, you have to press the X and select again. We'll select the surface again. Then we'll select the axis, rotation. Then we can change whatever angle we want. Let's say this is a half a cone, or we can use this is handy slider, and it's an increment of 5. If you can see here, let's move it a little bit. Plus 300. Now it's 295. So each step is 5 degrees. Okay, so let's go back to our hollow shaft. Don't want to save it. Okay, so if we want to try to draw something along the top, we have to select the axis. Same thing. Axis of rotation will be Z, which we are trying to do like something like a cap here. Okay. So we'll select the Z axis and either one of the other axes, either the X or the Y. Okay, so here we want to draw a cap. Okay, so we'll do the same. We'll select either the XZ or the YZ. Select the YZ for the sake of change here this time and hit create sketch. Okay, we'll do the cap on the top, so I will use the middle scroll wheel to pan, and then I'll start drawing using the line. Okay, we know that the thickness here is 5 millimeter. The whole thing is 50, and we have a hollow of 40. So we have 5 on this side and 5 on this side. Okay, and then you have to after you specify the dimension, don't hit enter like AutoCAD, because this will end the command. Instead, just after you insert the dimension, click the mouse noise, and the command will still be active. Okay, so now you have to draw till you reach the axis of rotation if you want to make it a solid object, complete solid object. I'll show you another example where we create a hollow cap. Okay, let's make it 20. Finish the sketch. Okay, I will try to do a small angle here, small fillet, sorry, here, just to make it a little bit more interesting. So I'll Control Z to go back to the sketch and use the modify fillet this with this, and automatically select the 3mm. You can change the radius as you wish, and we finish the sketch. Now we'll go to the revolve command. It already selected this face for me, this surface for me, so I only have to select the axis of rotation. Let's go to the home view. Okay, I'll select this axis, and it's already created a cap, but this time we make a new body, so we separate the cap from the hollow shaft, and hit OK. Okay, what I would like to do now is show you this simple thing with bodies and components. Okay, now when you have bodies and try to drag one of them, it doesn't move. But if we convert it into a component by using this command, new component, hit OK. Now we have OK. We converted the shaft. We can move it around freely. Okay. We'll go back to this later at the end of the tutorial. So I'll undo what I did, and we are back into two bodies. What else? Okay, I want to show you now something regarding revolve. I'm going to a new design. We'll select the XY plane, create a sketch. Now let's say if I want to do something hollow with the revolve command, I cannot start from the axis of rotation, so I will start a little bit after that. Let's say here I'll do some random shape. Okay, this is the shape that I want to revolve. I'll hit finish sketch, go back to my original view, or alternatively in this way you have to make, okay, we'll deal with this later. We'll set the revolve. It already picked this surface for us. Now we have to select the axis. Now if you incorrectly set the axis, you'll cause, okay, I mean if you select one of the edges, you will create a rotation around that edge. If you want to create something hollow, you have to make the axis of rotation slightly, depending on your dimension of course, slightly offsets from the edge. So let's select the axis again. We'll hit the X, and we selected the y-axis as an axis for rotation for us. We'll create a new body, and this is how we revolved around the y-axis. We don't need this, so I will not save it. Now we went back to our shaft and cap model. Since we are trying to do export to Inventor to do the dynamic simulation, we have to keep in mind that to do an assembly in Inventor, we have to have components. So now we will convert each component into each body, into a component. For dynamic simulation, I prefer you start with link 1, link 2, link 3 when creating components. So let's say, for example, that my body 2 is my link 1. Let's select body 1, create a new component. Okay, let's say body 1 is my link 1, so I'll select it first and create this component first. Okay, there we have our component. Then I'll select body 2 as the next component. Okay, now we have components rather than bodies, and this is one feature of Fusion, that you can move them freely. Okay, now I also like to color code the components. You can do this by two ways. Either you select the component and press A to bring up the appearance options, or right click, select A, to select appearance. Sorry. Now you have a lot of finishes. Let's go back for, let's to metal and aluminum, for example, and you will add your options by dragging them. Let's go for something else as well. Let's go for carbon fiber. So to distribute these colors, you will drag them and drop them to the component. Okay, it's preferable to do this before exporting, and close it. Now we are done with the basics of the Fusion 360, so I will show you how to export it. To export, you have to upload your project or your drawing into the cloud of Fusion 360 associated with your student account. To do that, you all have to do is save the project and select one of the folders created for you in your cloud for your Autodesk account. Here I already have a test drawing, so we'll call this test drawing 2 as well, and save it. And then we need to export it to Inventor file format. So we go again to File, and hit Export, and we'll select the type to be Autodesk Inventor file, and we'll press Export. Now, if you want to access this drawing again, this export will take a bit of time. Yeah, don't worry about it. Okay, until this finishes, let me show you how to access your files. You will hit these 9 squares for some reason, and select the folder that you saved your drawing into. In this case, it's new project for me, and this is the second drawing we did. Okay. Until this export's finish, I will show you the move and rotate and copy command on another drawing that I already made. Okay. Now this is already a component. No worry to worry about it now, and we'll select the move. Now this move copy command also has the rotate command. You can either move by these arrows. Okay. You can also rotate using the sliders. The only downside is the fixed increments. If you have to make it something very specific, you have to type it yourself. If you want just translate, it will decrease the options you want. If you want to just rotate, you have to select the axis. Now, in the free move, before it was in the middle, now it's in the corner. So I prefer you delete whatever he selects for you and select yourself. Now in this case, you can select whatever edge you want to make the rotation on. Okay, and the same goes for the rotate function. You select the axis you want to rotate and start rotating around it. Now we have also point-to-point move. Okay, this is the origin point, and I want to move it on top of this. This is similar to the AutoCAD way of copying and moving. Now, if you want to create a copy, you will do the translation or rotation, whatever you want to do with the object, and hit create copy. Now we'll have two objects, and this is okay. Now, for dynamic simulation, of course, we can, there's no need to do dynamic simulation shaft with a cap. So I have already made a crank slider mechanism to work on in the Inventor dynamic simulation. So these are our disassembled components for the mechanism. And I already exported them. And as I said, the components will be in the description. Okay, one last note for exporting. I'll show you what are the results of the export. It will be a compressed file. Now, you have an Inventor file and the components inserted. If you place this one, the Inventor assembly will be as drawn. Okay, it will be imported as it is to Inventor. But since we already need to assign joints and all, we only need to have the components. So you need only the components part from this compressed file. You either copy them or extract them. You know how to do this for compressed files. Okay. Now we'll close the Fusion. We're done with it. Okay, we'll run Inventor. And these are the components that are in the description. It's similar to the crank slider I showed you. And I have already renamed them according to the link position. So component 1 is my fixed link, and so on. Okay, so the first thing you need to do when Inventor is open is make sure the units are what you want them to be. You can hit that by hitting this gear, and here the default is in inches. We make it millimeters in ISO. Override, please. Okay. Now to create an assembly, simply hit the assembly and we'll start a new project for us to work on. Okay. Now we are in the assembly portion of Autodesk Inventor. Okay. So now we need to place our components to fix them with joints later on. We'll start by using this command, place component. It will take us to your browser. You will go to the place where you exported the components. For me, it's in the desktop, and you'll start by doing them in order. Not necessary to do them in order, but I prefer to start with the first link and move my way to the last link. You can either double click it, enter, or select open to start placing the component. Now when placing the first component or the fixed link or any other fixed link, before hitting the left click of the mouse, right click and place grounded at origin. So you want to ground at least one link for the mechanism to work. And select this option. Now you can place as many components as you want if you have duplicate components. And if you don't need to place duplicates, you just press escape and we'll go so on with placing the rest of the component. And now we have our 4 components for the crank slider mechanism. And you can see here that component 1 is having simple overhead, that means it's grounded. Then we need to start by assigning the joints. Okay, now I'll show you what I was talking about when I was mentioning the views. Okay, see here I have to keep changing the view into this location since I draw in Fusion 360 with different axes. This is what I was talking about when talking about these axes and how you have to arrange them between different softwares. Not a big deal, but maybe it's for your convenience, you know, if you take it into consideration. Now to place joints, you will press on the joint command. I prefer to select the type before assigning the joints or the location of the joint. Our first joint will be this one with link 2, which is a revolute joint, or here we call it rotational joint. Okay, you select the upper link, you will select link 2, then select link 1. Okay, this way, and it will move it for you. And it will show you a small animation of how the joint works to double check that you have assigned the correct joint and what you exactly want. And you will OK. You will assign another joint now between this link and this link. As we said, we'll select link 3 first and link 2 first. What we are selecting is the joint location and the axis of rotation as well, which is perpendicular to the selected surfaces. And it will move everything for you. You don't have to worry about moving or assembling the component. And it keeps your last selected joint intact. Okay? You press OK again. Let's make our last revolute joint. This surface with this surface. Okay, we'll hit OK. Now we want to assign slider joint between link 1 and our link 4, which is the slider. Okay, so select slider. Later on, the slider gets translated into prismatic in this location. So don't يعني it's fine. يعني slider will be prismatic here. If you want to refer to it later, which we'll need. Now, if you want to select a point on this plane, طبعا we need to select link 4 before link 2, link 1. But this is to show you a tip. To hold this plane, you have to press Control. And then you can move your mouse freely and select one of these points. Okay? So now I'll select the edge here with the edge here. So select this plane, hit Control, and select the edge. And this shows a correct orientation. Now when I hit OK, it will bring back the assembly together. Okay? This is not supposed to happen. Okay. So you can drag it yourself. And we will make sure it was working as we like to do, because it was mirrored in this way. We can avoid that by placing constraints, but in this case, it's not necessary. We can just move it to the desired location. Okay, you can double check your mechanism is functioning by using your mouse and dragging object around. So now we have our joint set up. We have the components assembled together. We'll go to environment and press dynamic simulation. Now you have to increase the time. 1 second is not enough by changing it here, and automatically give you 1000 frame, and this is also 1000 points on the graph. Okay. Now when you hit play, nothing will happen here because we didn't assign any parameters. Okay. And you want to access anything else after pausing the animation or the animation is done, you have to press construction mode. Okay, and to reset everything for you. Okay, so this is our first revolute joint. Okay, see here, this is what I was talking about. The slider is called prismatic, and what we assigned as rotational is here called revolution. It means the same thing, but this is to keep in mind. So we want this to rotate around this joint and make the slider move back and forth. So we'll go to revolution 1, right click and select properties. Go to the second tab and we'll discuss all the options here first. So you can go to a specific degree. Okay. If you want to take the mechanism position at a certain degree of link to the joint. I'll give you another example here. Let's say if this is 65, what's the location of the slider? How the mechanism looks like. Let's take 29. Let's take something else. 265, and so on. If you want a certain position, you can assign it here. Now we can add a torque. You will hit enable joint torque, and you have two options, either a grapher or a constant value. I'll show you the grapher. Basically, grapher is the input torque in this case. We're talking about joint torque. The input torque here, if you set the first point, let's say 10 Newton meter, the second point it's 10 Newton meter, which is automatically has been done here. It will give 10 Newton meter of torque along the 10 seconds. But if you want to make it gradually increasing, we can set the first point, sorry, to 0. Okay, why it's not updated? Okay, he assigned both of them because the slope is 0. So let's make the slope 10. And here the torque will be gradually increasing along the 10 seconds of simulation. Okay, I'll not use this one for our dynamic simulation. So I'll go and have a constant rotational velocity to this joint. So enable imposed motion. I'll not have a graph. I'll have a constant value of 60 degrees, for example, and I will have OK. Now you can test it right away. You will see that your mechanism is working as you intended to be. Okay, you can hit pause before starting simulation. You can keep it running to get all the values, but it's up to you. And you have to press construction mode to go back into the options here and enable more options up. Okay, now we have something to discuss. Gravity is a great effect on your mechanism and how it works, and some mechanism like pendulums rely on gravity as the driving force, in fact. So by default it's not defined. You have to define gravity. It's already in the okay, it's already given in the default location, but you have to double check and select the direction yourself by selecting vector component, and you will give value in the direction that suits your mechanism placement. So I'll make it minus 9810, sorry. It will be this direction, which is correct. Right, okay. We'll not use gravity in this simulation, so even if you define it, you can always suppress it. Or if you want to study the effect with gravity or without gravity, you can keep it, you can toggle it on and off, as we did. Okay, now to obtain the graphs, which is the whole point of dynamic simulation, to study the motion, you go to output graph. And from the output graph, you will go to the standard joints. Let me expand this. And we'll show you since this is a crank slider, we will be interested in the position of the slider. So we'll go to standard joints and select the prismatic joint, expand it. Let me show you here more of the options. So we'll have 5 graphs to plot here. You can plot each one one at a time or multiple one on the same graph. I'll show you how. So this is the position. Now before continuing into other graphs, I want to show you the mechanism animated and the graph working at the same time. Okay. Now at the first time you open the output grapher and run the animation, it will start simulating it and giving the graph. And here is our data plotting. These are 1000 data points. Okay, let's hit animate again. Oh, it's not working. Yeah, move it to the beginning. Okay. Now we confirm that this is correct here, and this is exactly what you want, since at this point the direction of the slider has flipped. Now it's moving. So when the animation reaches this point, it should start going back. Okay. So how smooth this will depend on your computing power, but this is quite good enough. Now you can start showing different graphs, and you can eliminate each one as you want by selecting one of these. Okay, let's go back to the position. See, since we selected 100 frame or 1000, sorry, 1000 frame, here we have the 1000 data points we selected. Okay, and you can extract them to maybe make it relative to the position. We want to change these data into relative to the crank slider mechanism that we have. Okay, this is in millimeters, since we selected the units before starting anything in the assembly. That's it for Inventor. This is the basics of dynamic simulation.